Let's go and take a look at lesson 3.5, do a quick review of that. In lesson 3.5, we're now looking at derivatives of trigonometric functions. And so first, make sure you're comfortable with sine, cosine, secant, cosecant, tangent, cotangent functions and have a sense of they are functions, right? They're just like any other equation. They just look a little different, right? So when we talk about sine of x, it represents something, right? Graphically, it looks something like this. But trigonometric functions many times are considered cyclical functions or periodic functions, because if you notice, their graphs repeat themselves over and over again. There's some repetition in them, so hence we call them periodic functions. So they represent things in the world that are periodic. Lengths of day, right? They go up and down. The temperature during a day, our tides, right? How do we know if it's going to be a full moon or half moon, right? Or how much percent of the moon is showing, right? That's all cyclical. And so anything that is cyclical in our world can be represented with a trigonometric function, or we try to do that. Also, trigonometric functions occur with geometry, triangles. And so we have these two kind of distinct areas of the study of trigonometric functions. Now, when we take the derivatives, we're still interested in the rates of change, how fast they're increasing or decreasing. And what you're going to do for this, you'll see right here somewhere. Where do we have? How we get the derivatives of these, right? But we're not deriving them, we'll be using, right? You'll be remembering or memorizing the derivative of sine x is cosine x. And it's an amazing kind of actually fact that the derivatives, the rates of change, are related to each other. The derivative of cosine is negative sine. And again, you can see that just by, again, what's happening with the graph, increasing or decreasing. There's a proof of these. And so again, math majors may want to spend a little bit more time reading these and trying to understand them. Again, you may not fully, but you should appreciate where those shortcut formulas come from. So it's worth reading and looking at the limit definition and then seeing how that the derivative of sine x emerges as cosine x. So spend some time on that. And then you take the derivative just like any other function, right? We use product rule, quotient rules, different rules that we have. And so you can see, take the time here to really look at the breakdown, right? This is a product rule. The derivative of the first one times the second, plus the derivative of the second one times the first. And again, you apply those formulas to, or those identities for trig functions and the derivatives. And you'll then see it simplifies into this. And then, of course, spend time. You remember, you have answers to the checkpoints in the book, so you can check your work here. This would be a product rule. And you notice, you will see that each of those, again, looking at it just to review the product rule, see again that these derivatives right here, it's a function times a function. That's what we have here, function times a function. Sometimes we call, there's your u, there's your v. And so your f prime of x, right, is going to be u prime v plus v prime u. And then you say, oh, u is sine x v. And so what is u prime? U prime is cosine x, v prime is negative sine x. And then you just substitute in there. So f prime would be cosine x, v is negative sine x, and then plus v prime, sorry, I messed up already, huh, a little bit, times v, right, v is cosine x, I'll get there, v is times cosine x, and you have v prime, which is negative sine x, times u, which is sine x. So you'll see you get cosine squared x minus sine squared x. And then always be aware that sometimes this simplifies into some identity. So we'll clear that. There we go. And so you can continue on looking at, again, the different examples here. This would be a quotient rule, and then you would apply it, right? Apply the quotient rule there. Quotient rule here. You can actually, again, one more thing to show you. Sometimes you will see, and again, depends what resources you're using, where else you're looking for some help, you'll see that some people are going to use the quotient rule on this. So use the quotient, I could spell that. Or someone can say, you know what, that's the same as, you can use, someone says, well, I can use the product rule too. And then what that turns out to be is x times 1 over cosine x, which then is x times 1 over cosine is secant x. And so that maybe you want to just do the product rule instead of the quotient rule, and you get the same answer, but it may look differently. You like what you simplify your expression may look differently. So use this, the quotient rule, or use this, the product rule. So something to keep in mind as you go through it, because the trig functions sometimes simplify differently, right? And so your answers or the answer key may look differently. So make sure you're aware of that. Where do we have the function? So tangent, right? Where does the rule come for tangent derivative? You're not going to derive it. You're going to remember the derivative. Tangent is secant squared. As you work that out there. And then you'll be amazed to see what is the cotangent. Derivative cotangent equals negative cosecant squared. Again, based because of those identities and the relationships between them. And you will memorize this. So put this to mind here so that you can easily take the derivatives of trig functions. And then we apply the same things. You can take first derivatives, second derivatives of trig functions, because they're just like any other trig function. I can find the slope of the tangent line. So hopefully that helps a little bit. Again, hopefully, again, you're gonna, as you do some of these, sometimes those identities pop up and you look at an answer and you say, you know what, that's not exactly what I get. And you're probably doing it right, but you just want to be aware of the different identities from your trig class that sometimes emerge in the calculus.